Hello everyone. On this clip I want to show you basic calculations related to the production function. I know you have an explanation in your textbook, but just to make sure that you get this, here I go. On this table 5-5, I want you to notice a couple of things. Number one, here you have a fixed input, capital, and as you can see, is not going to change. It always stays at 2 units regardless of the amount of output that you produce. And number two, you are going to have a variable input L, labor, which is the one that in the short term is going to be variable, or increasing in this case, increasing by 1 unit. So this analysis of the production function assumes that you are in the short term, or in some other books you find these as the short run, the same thing, right? So this is the short-term analysis of the production function. So notice that the change in L, and this is going to be useful for the calculation of marginal product in a few seconds, is always 1 because we're increasing the number of units of labor by 1. So this could be the change from 0 workers to 1 worker, 2 workers, 3 workers, and so forth, while holding the number of units of capital, and this could be the number of machines, some sort of equipment, fixed. Now, notice that as you increase the amount of labor, the level of output increases from 0 to 76 when you hire 1 person, to 248 units when you have 2 workers, 492 when you have 3 workers, and so on. Now, this is important because essentially what you are saying is this, that when you increase the amount of labor in this direction, the amount of output is going to increase. Now, notice something very important. If you plot this production, it's probably going to look something like this. It's not a straight line, but instead is increasing at a decreasing rate. So this is the level of output Q. How do I know this? Well, because look, when you calculate the marginal product, which is the change in Q divided by the change in L, this formula right here, marginal product of labor, you're going to see that the change from 0 to 76, well, of course, is 76. This is the first change in Q due to an increase in 1 worker. The second change from 76 to 248 is 172. The third from 248 to 492 is 244, and so on and so on. You keep going, but notice this marginal product starts increasing. It reaches a maximum right here and then starts declining. That's exactly what I mean when I say output is increasing at a decreasing rate, and that's why it gives you this shape, which is not a straight line, is not increasing exponentially, but is increasing at a decreasing rate. And finally, very simple, the calculation of average product of labor is simply dividing Q by L. So if you divide Q76 by 1, of course it's going to give you 76. If you divide 248 by 2, it's going to give you 124. If you divide 492 by 3 units, it's going to give you 164, and so on. So I meant to circle this 1, 2, 3 units. You have to divide total output, this column, by this column, which is a labor, to get this one. So again, I know this is pretty basic, but I just want to make sure that you had a bit more explanation just in case. And if you have questions, let me know.